Hi students, this is Gun, and as you know, this Wednesday is a holiday, so I am recording the laboratory work using this video. So you may just follow the steps and you can do the laboratory work, which is the designing of your programming language, especially for the expression. So let me just change the screen into the lecture material. So you can see the grammar for expressions is the topic of today. And you know that formal grammar is a very important method and also powerful, since you want to describe your languages in a very concrete manner. So you see from the last lecture, you have seen the very powerful tool, which is called the formal grammar. So even the formal grammar is defined as a quadruple. As you know, N is non-terminal, and T is terminal, P is a production rules, and S is a designated non-terminal. You know, the P is more important, most important. So usually, P is enough to describe it, since all the other components can be derived from the production rules, the set of production rules. So exercising how to write a formal grammar is the topic of today. And the target is an expression, since as you know, every language supports expressions. We'd like to write a grammar for an expression, but you know that there are several different representations for an expression. So we'll take a look of some of alternative form of an expression. So starting from a normal infix expression, the syntax for it will be extended to cover the prefix expression. So the infix means that the operator lies in the middle of the operands. So let me show you an example. So if you write an expression 1 plus 2, this is called infix, because the operator plus lies in between the two operators. So it lies in between, so it is called infix. But if you make plus comes first before the operands, this is called a prefix notation. And prefix notation is sometimes called Polish. So I'll tell about the reason why it is called Polish. And there's another alternative is the postfix. So the operand 1 and 2, and then you can make plus here. Then this is called postfix. So you may wonder if is there any special reason for misunderstood that this is 12? So you should safely assume that here you have spaces here to separate them. So it is a good idea to use spaces between the operands and the operators. The same is true for the postfix expression. So we'll take a look. Another alternative is Polish. And the Polish notation is adopted in an ancient language which is called Lisp. So Lisp is one of the oldest language introduced in the 1950s. So its lifespan is about over 60s. So over 60s. So it is almost 70s. So anyway, so it is one of the oldest language, which is very similar to the Fortran. So you can download the list, but we will focus on different version, which is called Scheme. So Scheme is a dialect of Lisp. So you may consider that Scheme is a simplified version of Lisp. And there are several implementations of Scheme, but the Scheme processor I'd like to adopt is Racket. So Racket is formerly known PLT Scheme and also formerly known Dr. Scheme. So it comes from very long history to get this specific implementation. So you can download the Racket from the following page. So let me show you this page. Just click of them and show you this page in another window. So let me reshare the Racket homepage. So from this Lucky page, you can just make a download here. You can see that there's download here. So just click download. And I'm currently using Windows 64 bits. So this is very good for me. So just click. This one. And while it is being downloaded, so I'd like to explain the Racket program in your previous slide. So to test Racket, select the language R5RS. This is actually version 5 of the scheme. So just select R5RS as your target language. Revision, fifth revision of an algorithmic language scheme. And try the following code in edit pane. So you can just type these things in the interactive pane, but it is good to save the result as a code. So please use edit pane. So it is already downloaded. So I just resharing the screen. What is this? Resharing the whole screen. Let's open this. So just click next, and several next here, and install. So while it is being installed, I'd like to explain this for them. You know that this is using a prefix. So it is using spaces here. Using spaces to separate the operands. And in order to scope the scope of the operator up to which operand it is in effect. So it is described by parentheses. So this 1, 2 is similar to 1 plus 2 in infix. And this times 3, 2 corresponds 3 times 2 in infix. And for these two things, you are defining double function. So double function is receiving a parameter. So this is a parameter. And the scheme is a typeless language, so it does not specify time. So it is actually dynamic typing language, dynamically typed language. So the body of the function is plus and n. So there is no return keyword. So you can decipher this in C syntax. Let me show this in C syntax. As you know, C is somewhat different to because you should specify type. So it is also good for Python syntax. So it is much like that, def, double up. So in Python syntax, you should use underscore instead of minus. So it is accepting n, and it returns n plus n. So in Python, it is interpreted like this. And this is just a function call. So you are calling that in Python, double up. The argument is 1,234. So it will print the result of 1 plus 2 is 3, and 3 times 2 is 6. Double up 1,234 is that adding 1,234, so 2,468 should be printed. So note that the expressions in scheme are written in prefix form, also known as Polish notation. So let me just check your record is installed properly. Okay, it was installed properly, so finish it. And from Start menu, you can just click Dr. Record. And I'd like to zoom in to Dr. Record. To take a look of how to select the language. So control, is this right? Okay, good. So from the language, just click here, choose language. And then there are several other languages, but you just select other languages here. And you can find there's R5RS. Okay, and then, okay. So the R5RS is selected, but the signal is saying that no language chosen. So you just click an execution for it. So let me just minimize this a little bit. Okay, so just run for it. So the language is selected R5RS. So you just type, the first one is plus 1, 2, and second one is times 2, 3, 3, 2. So you can just store this or save this in compiler. So in my favorite compilation folder, my code of compiler, so I'd like to make a new folder for the grammar. and then let's save the expressions of record source. Okay, just select and save this. And then you can click run here. So it is safely printing 3 and 6. And then you can just type the double function. So define double up of n is just returning plus n here. So when it was defined, once it is defined, you can apply double up of 1, 2, 3, 4, 1,234. Okay. And then you can run this again. Okay. So you're saving this. So you know that you safely run this code correctly. So note that the expression and scheme are written in prefix form, also known as Polish notation. So why it is called Polish? There's a footnote. It is named after Jan Łukasiewicz, who is suggested that notation in mathematics. So you may think Polish notation is weird at first, but in typical languages such as C and C++ and Java, you use that that prefix notation, Polish notation, frequently. So, for example, you may think that this is much like add function. So add 1, 2. This is valid in C. So how about this? This is a multiplication of 3, 2. How about this? It is a double up. 1, 2, 3, 4. But the weird aspect is that it is inside, the function name is inside of the parenthesis, and you didn't use comma here. Just list up the arguments just after the function. So this one, well, sorry, this is U, 3, 2. For this one, it's just double up, double up of 1, 2, 3, 4. So this is in C or C++ domain, and this is in scheme domain. So this can be well understood for most programmers, except the locational parentheses. So you just move up this double up of 1, 2, 3, 4 is okay. So one of the notable features of scheme is that it has a unique syntax for everything, even with the control structure in that language. For example, the following function f returns the absolute value of x, and there's an if expression. This is much like a conditional expression. So if x is greater than 0, so this can be represented in C. So x is greater than 0, then it is returning x, then x, else minus x. That means else minus x. But you need parentheses in scheme and reset. Since this is your first operand, this is your second operand, this is your third operand. So you are in fixed notation for representing this. But in scheme, you need parentheses, all of them. So in Python, you can do the similar thing with the condition at the middle. So if it is greater than 0, if it is, then x should be returned, else minus x should be returned. So you can take a look of the second approach of Python, because let me just invoke idle for this. So it seems not working correctly. So let me just check Python. Not here. Okay, Python idle. Okay. So you can find out. So let me enlarge this a little bit. So if you define x is minus 3, and you want the value of x if x is greater than 0, else minus x, then 3 should be returned. Okay, so this is much like a conditional in C expression. But that expression is also used in scheme. So if you define, so let me enlarge this a little bit. If you define function f accepting x, and if x is greater than 0, then x, else minus x. So this is f function. So f minus 3 will return 3. So f plus 5 will return 5. So let me just execute this, and you can check the result. So I can save this. So this form of expression is called S expression, which stands for the symbolic expression. So S expression consists of two things. One is atom. You know that the atom, you are atom here, but atom, much like the integers 2 and minus 3 are called atoms. And the application, function application, is that a form of the function and the arguments a1, a2, dot, an. So you have two kinds of expressions, atom and application. And application is in a form of list. So it is called, originally called, list processing. So today's problem is that designing the grammar for expression. So as a warm-up exercise, you can extend the following expression grammar to support multiplication operation for plus, just like asterisk for multiplication, and division for slash for division. So it can be easily extended. So as you know, you have five production rules. This is just a shorthand of these 5 rules. Okay, and you know that everything lies here is called a non-terminal. So n equals e and n. And terminals, t equals everything which is not non-terminal. excluding the meta symbols. So plus, minus, 0, 1 terminals. And you know that these 5 rules is called the production rules. 1, 2, 3, 4, 5 production rules. And this dot symbol is equal to E, which is the left-hand side of the first production rule. So you know that this is the left-hand side of the first production rule. So it is regarded as a star symbol. So you just enumerate the production rules for describing your extended grammar. So as a second exercise, extend your grammar to support conditional expression. So you may adopt either C style or Python style syntaxes. So as a final exercise, convert your grammar to support Polish rather than infix notations. So you can get a hint from the racket. So the important part is that writing grammars here. So you may either take a scheme syntax or C style. In C style syntax, you can use the much like this function and argument 1, argument 2. And in the scheme style, you know that function with argument 1, argument 2. Okay, so anything will do. Based on this, the experiment, you make a report with references. So you can write a report in Korean. So your report contains the following materials: the grammar for the warm-up exercise, which is this one for 1, and second one, grammar for the second exercise as a second exercise, 2. No, there is a second exercise, warm-up exercise, and third one is the grammar of the third exercise as a final exercise. Take a look of the final exercise, and with the converted expression in your language. So what is the converted expression? You have seen various scheme expressions up to now, but you just convert it in your form, okay? So these things should be specified and what you have learned in this laboratory. But as you know, this is your first time to doing a laboratory work with plenty of time. So I'd like to just give you some more chances to get bonus points. So the first bonus point may be performed that your grammar should support looping expressions. Up to now, you have seen conditional expressions, but you may support looping expressions, but you have to consider what is the returned value from it. What is the returned value? You have considered return value of your looping expressions. And second one is that you have to extend your grammar to support function definitions. So this can be your second bonus point. So if you want to support this kind of extensions, so please specify them in the middle of here. So in any case, you have to justify your work. It's really working to write practical programs. I mean that non-trivial programs. Hello world is not possible, but just how about the insertion sort or finding the maximum value from a list. So in any case, you have to justify your work is really working to write practical problems. Okay. So if you have any question, so please use your Q&A board, and the format for the report will be posted with this handout. Okay, so have a nice holiday and